This will. Hello ladies and gentlemen, today will be an instructional video on the Hotwire. If you're not familiar with the Hotwire, well, that's to be expected. Seeing it is 2019 and the LED is king, the Hotwire's time is essentially over. But it does not have to be so. Today I will be going over the basics of what the Hotwire is and why it is still king of setting stuff on fire if you want to use a flashlight. LEDs may be the most efficient and often powerfulest of flashlight and illumination tools. However, LEDs do not produce as many infrared wavelengths of light as an incandescent does. While an incandescent may seem or appear to be inefficient, that is only in the visible spectrum of light. An incandescent still produces 100% of its energy into heat, whether it be directly or indirectly through photons that then strike a surface and are absorbed and turned into heat. Thus, if your goal is combusting things into fire, the incandescent is the most efficient illumination technology. How does the Hotwire work? What is a Hotwire? Well, a Hotwire is when you take a standard incandescent bulb and you overdrive it. It's sort of like overclocking a computer. A filament in a flashlight bulb, as I have drawn rapidly here, is essentially a wire of tungsten carbide that is twisted so that its overall length is shorter. In essence, sort of like your intestine is twisted so that it can fit in a smaller confined space. Otherwise, bulbs would be very wide and their total intensity, their surface brightness, would be low. This wire, its length, is how much voltage is necessary to have it glow, and its thickness is how many amps are necessary to make it glow. The combination produces the wattage of the bulb. Every bulb comes with a lifetime, or an expected life till failure. This is approximately how many hours the bulb can be cycled on and off and run continuously until the filament, the tungsten wire, has evaporated enough or become too frail from being turned on and off so many times that it will break. That's how an incandescent bulb dies. Essentially, the wire is broken and you can no longer create the short between the two posts that carry the electricity, and thus no light is produced. The shorter this overall runtime is, the less bulb life you design into a lamp, the more efficient it becomes. In essence, there is no such thing as a bulb lifetime of a tungsten filament. There is only what is assumed by scientists to be the approximate lifetime. An example that being that you could theoretically run the incandescent bulb that's in this light at 1/4 the voltage and it would run for decades. You could pretty much never burn it out. On the flip side, if you put enough voltage through this lamp and supply enough amperage, you can create its lifespan to be nothing. You can blow it out instantaneously. So working between the margins of unlimited lifetime and low output, or extremely short lifetime and maximum output, is how a Hotwire fundamentally works in practice. The idea being, you take a bulb, and if that bulb says 100-hour lifetime, and it says 12 volts rated, you increase the voltage to say 14 or 15 volts, and its lifetime goes down, but its total illumination increases. A 100-hour bulb run so that it is only maybe possessing 1 hour of total lifespan at like 15 volts or 16 volts will be much more efficient and much brighter than it came originally from the factory, or at least it was rated originally from the factory. So that in essence is what a hot wire is. You take a bulb, any bulb, that can run at a voltage a flashlight can supply, and you increase the voltage until its lifespan becomes so short that you're cranking out the maximum amount of power that it can essentially handle without dying. In this lamp, for example, it is using a 90-watt projector bulb rated for 12 volts. However, it has a 5,000-hour rating. So by increasing the voltage to over 21 volts with a soft starter, which I'll get into later, I can bump up the wattage to nearly 190 watts and go from 1100 lumens to the 8,000 that this monster produces. I'm going to briefly cover what a soft starter is. It's probably irrelevant at this point because in 2019 I don't even really know where you could find a soft starter. You could probably make one yourself. But how a soft starter works is an incandescent filament has a sort of thermal resistance and inertia, and if you shock it too hard with too many amps too quickly, it essentially just sort of vaporizes. That's how a bulb dies, as I had noted, was when the filament is broken. But in this aspect, a filament undergoes the most stress the moment it's turned on. After it's turned on and is warmed up, it can actually run much longer at the same wattage than if you were to just turn on and off quickly. That's the reason why old incandescent bulbs that were in fixtures that some of you may, I would assume all of you are still familiar with, they would always die when you turn the light on. They died when you turn the light on because if they were already getting close to the end of their life, that shock of power does them in. So a soft start essentially weans on the power so the filament can warm up before the maximum power is flowing through it. This greatly increases the ability to overdrive the filament. It's not always necessary, unless you're really pushing the boundaries and you're trying to eke out that maximum efficiency. I can just turn this on. The black table will probably help make it not too bright. So when I turn this on, see how that slowly ramps up in brightness? That allows the filament not to be shocked and killed immediately. This bulb is so overdriven that if it didn't have a soft starter, it would instantly be destroyed. There's no way that it could survive as many volts as going through this. This also has 3 modes and works by PWM, pulse width modulation, I believe it is. So it's pretty much flickering current at the lower settings through the filament at a rate where the thermal inertia doesn't show the flickering because it stays glowing at consistent temperature. It's just fancy talk for that's how you get different brightnesses out of an incandescent. Now, the more you hotwire an incandescent bulb, the more efficient it becomes. A typical 60-watt incandescent lamp, 120 volts that you would have in your house, only runs at about 16 lumens per watt, which is atrocious. LEDs are now well over 200 lumens per watt. The higher you increase the voltage on that incandescent bulb, and the shorter you reduce its lifespan, its efficiency actually increases continuously. It increases right to the point where it essentially has infinite efficiency, but it runs infinitely little. It doesn't have any runtime. If you put 1 billion watts through an incandescent bulb, I mean, and it was only rated for 1 watt, yeah, it's 1 billion times more efficient, but it only run for 1 billionth as long as it was designed for. So there is a point of sort of running out of what you can really do there. A incandescent bulb hot wired to about a 1 hour lifespan, you can probably push out close to 35-ish lumens per watt, which is really quite good for an incandescent. If you put a soft start on an incandescent bulb, you can get that number up to 50, essentially. That's pretty much the theoretical limit. I don't know of any bulb testing that's ever shown more than like 49 lumens a watt with like minutes, seconds of bulb life. That's technologically pretty much what you can push tungsten-carbide, not tungsten-carbide, just standard tungsten to do. So yeah, that's how a hot wire works in theory. So I've told you now how a hot wire works, how a tungsten filament works in a bulb, mildly. There's things I've missed, like the fact that if you underdrive or cold wire a lamp, at some point your efficiency becomes so garbage that it doesn't even make light anymore, not visible light. And even though your bulb lifespan becomes infinity, the deposits, the tungsten deposits, are just kind of like flaking off of the lamp at that point, off the filament, and will gather on the glass envelope, and you'll start losing light just from making it hard for light to get through it. It just doesn't really make sense. I mean, just from a standpoint of can it be done? Yes. The best example would be that, I'll leave a link in the description, that firehouse that has a bulb that's been running for over 100 years. It's an old carbon filament lamp, and it's like 115 years old or something, non-stop running continuously. It's very underdriven. It has a very robust filament inside of it, and it will just keep on going. Its lumens per watt is probably like 2 or 3. It's probably garbage. But it just goes to show that an incandescent can run even longer than an LED if you just underdrive it. Likewise, an LED will run for a very, very long time if you underdrive it. LEDs are a lot more finicky than incandescents, though. You pretty much have to hit them with the voltage they want and the amperage they want. You have to really make sure you cool them. A lot of people that don't have high performance LED flashlights do not realize an LED, while making less overall heat because it's more efficient and more of that energy is turning into visible spectrum light, an LED struggles to get rid of its heat. You have to direct the heat away from the chip, where with an incandescent, besides destroying the filament, it doesn't really matter how much heat you make. It doesn't really matter where it goes. For instance, in this light, the heat inside this head fixture can hit 400, 500 plus degrees. If I use my thermometer infrared gun and I aim at the outside of this head, it will hit nearly 300 degrees on the outside. That's not really a problem for the bulb. It doesn't really care too much. It might reduce the life a little bit, but really all it's doing is trying to kill all the circuits, boards and stuff behind it for the soft starter, and trying to kill the switch and stuff. But the bulb itself doesn't really care. This uses a synthetic sapphire lens. I don't think so. It might use there's a name for it, for really high temperature glass lenses. It escapes me now, but I believe that's what this is using. Oh, I'm not pronouncing that correct. And it uses a chrome-plated titanium reflector, because an aluminum reflector in this would actually melt if you ran this for a few minutes, which is pretty impressive. And the lamp itself is suspended on a ceramic base, which is air-gapped from the circuit board, just to try and keep the heat isolated to the head and keep it out of the circuitry and the switch assembly. This is a rather complicated hot wire. This is kind of pushing the boundaries of what you can do in a stealth package where everything on the outside looks just like a traditional 60 mag light. There's much easier ways to make hot wires. There's much easier ways to make flashlights that can set things on fire. As of today, the only videos I can really find on YouTube of flashlights that can set stuff on fire are the Wicked Laser's torch, either the original or the newer version. And there's no reason why a consumer couldn't just build their own hot wire that can set things on fire instead of buying the Wicked Laser's torch. It should be noted the Wicked Laser's torch is both half as powerful as this light and runs 4 times less, meaning, I'm sorry, it has 1/4 the total runtime. This light is jam-packed with lithium polymers from tip to tip, where the little Wicked Laser's torch is a fairly small light compared to a big 60 mag light, so you're really pushing the batteries to do a lot. So, I digress. How to build a incandescent for cheap that can set things on fire. Probably the best avenue is to just get MR16 lamps. These fit in a mag light head, and I will link in the description to a gentleman on Candle Power forums, flashlight enthusiast forums online, called goes by 5 Mega, and he sells adapters that allow you to use, I believe they're called G5.3 socket adapters that go right into mag lights, and you can run these MR16 bulbs. These bulbs you can find in the hardware store, Home Depot, Lowe's, etc. They are, as soon as you see them, if you're familiar with these, you've seen them in the stores. MR16s come in usually low voltage applications like 12 volts, and they go everywhere from 10 watts all the way up to 75 watts, and in extreme examples like this one, more. A 75 watt MR16 bulb, which you can find everywhere, has over 4,000 hours of rated life, which means you can up the voltage and overdrive the crap out of it. And while it's rated for 12 volts, you can hit it with 18.5. Yeah, 18.5 volts. Sadly, my MR16 modded light is not in this state. It is somewhere in my closet back at my family's house. So I can't give you an example of one running, but they set fires to stuff real good. That 75 watt bulb ends up being around 137 to 141 watts, give or take. Super efficient, really powerful, very simple. Instead of having to source a high temperature glass lens, a high temperature reflector, an expensive adapter socket, all you have to do is buy that little tiny adapter from 5 Mega, and you just buy a 75 watt MR16 bulb that comes with a glass lens. This one does not have one. And then you just drop it in and you're good to go. I mean, you need the batteries, of course. What kind of batteries? Well, I'll show you. There's my ghetto resistance mod right there. You don't want resistance. And my ghetto spacer, which is just a bolt. And one of many batteries that are in here. One of 5. So these are IMR 26650 cells. And they're rated for 5200 milliamp hours. They're rated for 15 amps continuous discharge, which is plenty for most applications, and bursts up to 30. They're pretty much a bigger, more heavy-duty version of an 18650 cell, and you definitely want the IMR version instead of the lithium-ion version, as the lithium-ion batteries do not discharge as quickly. So 18.5 volts, you need 5 of these. Actually, there's exactly as many batteries in this light as set up for an MR16 build, just by coincidence. This used to run a whole ton. Actually, I'm gonna go get it. This used to be the powerhouse inside of this mag light, which was 18 high discharge AA batteries. These Elite 1700s, I believe, are the highest discharging, rechargeable, non-lithium AA batteries you could get at the time. This light is circa 2010 to 2008. It's over a decade old at this point. Battery technology has greatly increased since this was a thing. So this pack made over 20 volts, but under voltage sag, you could only really expect 1 volt per cell instead of the 1.2 they're rated for. So you were getting about 18 volts. And with these IMR cells, each one of these are rated for 3.7, which is essentially 3 of these batteries. So you could do with less, essentially, volume of cell. You could get 0.5 more volts with these, and instead of 1700 milliamps, you could get 5200 milliamps. So this light went from having approximately 8 minutes of runtime to well over a half an hour, which is not really viable when your light gets over 400 degrees. You have to turn it off, or maybe after 10 minutes, absolute maximum, or you're going to start melting stuff inside the light. Not the bulb, ironically. That will keep on going. What am I missing here? Probably not much of anything. Incandescent is still a thing. You don't have to go to LED. And if you really want to be hipster now, it's going incandescent, because everyone's got LED lights. That was cool a decade ago, but Wait until your friends see your incandescent that's brighter than their LEDs. They're going to be like, what? One final thing. These MR16 lamps, the 75 watt bulb that's rated for 4,000 hours being overdriven at 18.5 volts, will make over 4,000 lumens. 4,000 lumens! That's crazy. 4,000 lumens is approximately the same brightness as the Wicked Laser's torch. And this is more wattage. This might actually be brighter. It might be a little bit more like 4,800 lumens. So with an MR16 bulb, a 5 mega adapter, 5 of these cells, you can build your own mag light that will be brighter, run longer, set things on fire faster than a Wicked Laser's torch. Good information to know. Alright, until next time, feel free to like and subscribe, and remember I have a Patreon, and if you want to see more awesome things built and shown off and described on how they function, feel free to support me on said Patreon. Also, feel free to ask questions in the comments if you have any.